Hello everyone. So in this video we will be looking at another binary search question. So that is division of two elements using binary search. So what is the problem is states that we are given two numbers, for example x and y, and we have to find what x divided by y gives, but not without using the division operator. Instead we will be using the binary search algorithm. So what will be the basic idea of this algorithm for this like question? How will we use binary search? It's like we know our answer will lie something in between 0 to I can say infinity, right? So my answer will lie between this for all the positive ones. We can consider for the negative values later on. That is a special case. We can handle it just with two line of codes. So my value will lie something in here. So x divided by y I know will be something as q, and at each mid we will find the mid and we will check out whether it is my possible answer. So like I can write it as like this, right? So x is equal to q into y, where q will be my mid, and according to that I will just update my answer. So for example, what happens is if my this mid into y, if my mid into y is less than x, right, I'll just move my low. I will move my low. This is my low and this is my high. So I'll just move my low is equal to mid plus 1. And if my if it is not the case, I'll just move my high to mid minus 1, right, or just to the mid. And when will my answer will be given? So it will be when my like y into mid minus x is less than equal to, I'll set some precision value, because if we use floats there will be some like 001 or something like that kind of difference, so I can ignore those. So for example my answer is 3.14 for some division, and my on division I'm getting something like 149. So I can just ignore all this, like, so these can be my set of answers. So how will the code look like? So there will be a function which will have two values, x and y, and for negative cases what will I check? I'll take a value int sign equals to 1, and if x into y, right, if x into y is less than 0, so I can just mark my sign equals to minus 1, as that will show that one of the value is negative. So for example, if I have something like this and if I multiply them, it will give me some negative value q. Either this is negative or this is negative. Okay, so now let us just dive straight into the coding part. So here I have Visual Studio Code open with me, and let me just clear this, and let me just take two values as an input, x. So let me take these two values. So I'll take int x and int y, and I'll take the input, right? And now I want to find, so let me just write a function find QUO quotient, and I'll pass in x and y, right? And I can just print it over here whatever the value I will get, and here I will write my function. So it will be a float one, because, or I can take it as double find q, and I will have int x and int y instead. Let me just take these as well, double as well, so I don't have to do any typecasting. And I'll start with the double all the way, double. So let us just double, double, right? All good. So now first of all I got to take care of certain cases, edge cases, right? So if my y equals to 0, I'll return 1e9, right? If my y is equal to 0, I'll return 1e9. So for example, if I am having something as this will be specifying x divided by y, so if my y is 0, I'll just return infinity or not defined, so that will be treated as not defined. So I need a low, so double low equals to 0 and high is equal to 1e9, and I'll take a precision of double precision is equal to 0.001. This precision is taken for this value. So for what I was saying, this example, so if I have 3.15 and 3.14 and 3.149, so I can consider them as my answer, right? And after that what I will do is I'll take a int sign equals to 1, right? This is for the sign purposes, like either whether it is a negative or a positive one. So if it is less than 0, I'll set my sign to -1, right? And now comes the binary search algorithm. So while 1, so till it is true, I'll find the mid. So double mid equals to low plus high minus low. So using this way formula, this way we can like avoid the overflow condition. I'll prove this in another video, how we can avoid the overflow using this. So if uh, get abs, okay, y into mid, get abs y into mid, we will write this abs function mid minus x, it is less than equal to precision, right? So what is this? Like if I divide something, so if I have something like here I have y, here I have a quotient, here I have something values, and here I have r. So what I can do is I can write like uh, x equals to y into q plus r, right? So this is what has been manipulated over here and written in a different way. So now if we are done with this, after that what we'll be doing is, so if this is the case, I can just return that mid is my answer. So I'll return mid. Else if my y into mid is less than x, my low will be mid, else my high will be mid. And in the end, right, so in the end, if there is nothing to return, what I will be doing is I'll just return a 0. Like 0 will specify it is not divisible, or I can just return 1e 1e9 again, right? So here is the function, and now let us just try to run this and check whether it is right or wrong. So here is the complete code. So now let us just compile it and run it. So binary crch binary search dot cpp slash output binary se. Okay, so get tabs was not declared in the scope. Okay, we haven't made this function. So double get abs, and it will be getting a value double I. And what this will be doing, if I'll return I, if I is greater than equal to 0, I'll return I, otherwise I'll return minus of I. So this was just to check the sign one thing. So now I'll just compile it again. Now let us just run it, binary se.exe, and let me just put in the values, like for example 22 and 7. So I'm getting 3.14276. so let us just verify it once. So right, so the value was so I was dividing uh, 22 by 7, right? So I am getting 3.142, so I am getting 3.14276 almost. So this is my answer. So if we try another one, like let us just try like perfectly divisible thing. So like 30 and 10, so I should get a 3. Okay, I'm getting 2.997, so that was just a precision thing we have done here. So this will, a little bit error will be here. So that was all for this video. So in the next video we will be looking at some another questions. So stay tuned for those video, and I hope you enjoyed this video, and do like the video and hit the subscribe button. See you all in the next one.